Hello students, in this video class we are going to discuss a program which is related with method recursion. And the question is, write a Java program which will take an integer number as input and convert it to its octal equivalent. Okay, write a Java program which will take an integer number as input and convert it to its octal equivalent. Okay, and display it. Use the method recursion technique. Use the method recursion technique. Okay. See, this program is similar to the decimal to binary equivalent, but there is only slight change. Okay, what that change is, I will tell you. See, in case of decimal to binary conversion, listen, let me tell you. In case of decimal to binary, if the decimal was 3234, okay, 3234, okay, and to find its equivalent binary, what was the technique? We were dividing it by 2. Listen, 2 ones are 2, 2 6 are 12, 2 ones are 2, 2 7s are 14. What is the remainder? 0 is the remainder. 2 8s are 16. Okay, then 1. 1 is 0. Oh, sorry, 1 is smaller. Okay, 1 is smaller. So it will be 0. Okay, then 2 8s are 16. So remainder 1. 2 4s are 8, 0. 2 4s are 8, remainder 0. 2 2s are 4, 0. 2 2s are 4, remainder 0. 2 1s are 2, 0. 2 1s are 2, remainder 0. 2 5s are 10, 0, remainder 1. 2 2s are 4 and 2 5s are 10, remainder 0. 2 12s are 24, remainder 1. 2 6 are 12, remainder 0. 2 3s are 6, remainder 0. Then 2 1s are 2, remainder 1. Okay, 2 1s are 2, remainder 1. Clear, na? Now, see the situation. The process was continuing. In the very first step, the value of n was 3234. In the second step, the value of n became 1617. In the third step, the value of n became 808. In the fourth step, the value of n became 404. In the next step, the value of n becomes 202. In the next step, the value of n becomes 101. In the next step, the value of n becomes 50. In the next step, the value of n becomes 25. In the next step, the value of n becomes 12. In the next step, the value of n becomes 16. In the next step, the value of n becomes 3. And this was the base case. Okay, this was the base case. Okay, when value of n is 1, we were returning 1. If n is equal to 1, return 1. Okay, return 1. If you have not watched that video, go and watch first for that. Okay, so this was the base case in case of decimal to binary. Okay, decimal to binary conversion. Now listen, decimal to octal. Okay, decimal to octal. Now what is the change? I will tell. Just listen. Listen. 3234 whose base is 10. When I say base is equal to 10 means the number belongs to decimal number system is equal to question mark base 8. It means it is asking to convert the decimal number 3234 into its octal equivalent. Octal means whose base is 8. Okay. Now listen, in octal number system, note in octal number system, 8 digits are used. 8 digits are used. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, digits 8 and 9. Digits 8 and 9 are not available in octal number system. Are not available in octal number system. Are not available in octal number system. Okay, that is the reason why the base is 8 in octal number system, because it uses 8 fundamental digits 0 to 7, and digits 8 and 9 are not allowed in octal number system. Now, how to convert it? See, in case of decimal to binary conversion, we were dividing it by 2. So similarly, in case of decimal to octal conversion, we will divide it by 8. So 8 fours are 32. Now 3 is lesser than 8. So 0, then 34. 8 fours are 32, remainder is 2. Okay. 8 fours are 32, 8 fives are 40. Yes, 8 fives are 40, 0. Remainder is 4. 8 6 are 48. Remainder is 2. So 6 to 4 2. Okay, 6 to 4 2. Yes, 6 to 4 2. Na? So 3 2 3 4 whose base is 10 is equal to 6 to 6. So no, 6 to 4 2. 6 to 4 2 whose base is 8. I can see here, when we are stopping the process, initially the value of n is 3234. Then the value of n becomes 404. Then the value of n becomes 50 and we have to continue. Then at last the value of n becomes 6, which is what? Which is less than 8. It means if the value was 8 or greater than 8, we would have continued the process. But since the last value of n is coming less than 8, so we are not dividing it. Okay, so just from bottom to top, we are writing the digits, that is 6242. So what is the base case in this case? In this, what will be the base case? The base case will be if n is less than 8, we need to return the same number. We need to return the same number. Yes or no? We need to return the same number. So return what? N. We will concatenate one empty string so that the value of n becomes string type. Okay, clear na? Don't worry, I will tell. Okay, listen. Listen. See, the method is, how to define the method? Public static string get octal. Okay, the name of the method, assume the name of the method is get octal. So it will accept an integer number and return the octal equivalent in string format. Octal equivalent in string format. What is the base case? The base case is if the value of n is becoming less than 8, then the method should return n concatenated with one string. What is the reason? So that the value of n becomes string. Okay. Else return and then call the get octal method. Okay. See, when the value of n is 3234, in the second step, the value we are getting is 404. Now, how this 404 is coming? 3234 divided by 8. Yes or no? 3234 divided by 8. So we will write here n divided by 8. Okay, n divided by 8. N less than 8, return n. Get octal n divided by 8 plus what? We will concatenate n modulus 8 value. N modulus 8 value. Okay. Now listen, I will tell you why. 3234. See. 3234. So 8 4s are 32, 0, 8 4s are 32, remainder is 2. Okay. Now listen, how we are getting this 2? The question arises, how are we getting this 2? We are getting this 2 by 3234 modulus 8. Means when 3234, that is the value of n. This is now n. This is n. So when the value of n is getting divided by 8, the remainder which is obtained, so we are concatenating that value. So n modulus 8 means 3234 modulus 8 means here it is 2. Initially it is 2. And then we are passing n by 8. What is n by 8? This is n by 8. This is 3234 divided by 8. This is the quotient. So n by 8 is 404. Now 404 is again getting passed to the same method. Now 404 is less than 8? No. So again the recursive case is continuing. Okay. So this is the base case. Okay. This is the base case, or you can say terminating case. Okay. This is the terminating case. Okay. And this one is the recursive case. This one is the recursive case. Okay, this one is the recursive case. Clear? Clear or not? Okay. Now listen. So how many steps are there? So the method will be called again, then again, then again. So I need to write the method 4 times. No? Okay, let me show you the dryer. Okay, let me show you the dryer. How it will work. Now you might be thinking, see, if you have watched that video, decimal to binary, then there will be no doubt. Okay. See, why we are using or calling the get octal method before plus sign? Because we want the result in reverse order. We want the remainders to get concatenated. We want the remainders to get concatenated in reverse order. That is the reason why I have called the method and then concatenated the remainder value. Okay. Let me show the dry run to you. Listen. Okay. See. Public static string get octal int n. Okay. If n is less than 8, so we have to return what? N concatenated with a string, empty string. Now why? Because the return type of this method is a string and n, the data type of n is int. So we have to convert this value of n to a string. That is the reason why I am concatenating n with an empty string so that the value of n becomes string. Okay. else part. What is the recursive case? Else part, I am calling the same get octal method, and here I am dividing the value by 8 and then concatenating with n modulus 8. Okay, don't worry, I will explain. Now listen. See, what was the value? 3234, na? Yes, 3234. See. So what is the value of n? The value of n is 3234. Okay, the value of n is 3234. Now 3234 is less than 8? No. So it won't return the value of n. It will go to the else part. The control will go to the else part. And in the else part, here it is written n by 8. That is 3234 divided by 8. So 3234 divided by 8. What is the value? 8 4s are 32, 0, 8 4s are 32. It is 404. It is 404. Okay, 404. Now what is n modulus 8? N modulus 8 means 3234 modulus 8. So what is the remainder value? The remainder value is, what is the remainder value? 34 minus 32, it is 2. So it is 2. The remainder value is 2. Okay. Now since the method is getting invoked, so let me write the copy of the same method. Public static string get octal int n. Okay. If n is less than 8, same thing, n is less than 8, return n concatenated with empty string. Else call the get octal method and pass n by 8 and concatenate it with n modulus 8. Same thing. Okay. I'm not changing anything because this is the copy of the same method, yes or no? Now listen. So this 404 is getting initialized to n. Now the value of n is 404. Now 404 is less than 8? No. So the remainder, yeah, the question is 404. Na? Let me check. Yes, 404. Okay. Yes. See, 404 is less than 8? No. So the else part will get executed. Okay. N divided by 8. So 404 divided by 8. So again, let me divide it by 8. So 8 5s are 40, then 0. So it is 50. Okay, the value 50 is coming. And n modulus 8, 8 5s are 40, 0. So the remainder 4. Okay, so 404 modulus 8 is equal to 4. Clear? Now since the method is getting invoked, let me write the copy of the method again. Public static string get octal int n. If n is less than 8, return n concatenated with empty string. Else call the get octal method and pass n by 8, concatenate it with n modulus 8. Okay, close the curly bracket. Okay, now listen, what is happening? This, the value of 50, here we are calling the method again. Nah, the method, I mean, we are not calling, the method is getting invoked itself. Okay, the method is calling itself. So the value 50 is getting initialized to this parameter and the value of n is becoming 50 now. That is the reason why I told you, first of all, the value of n will be 3234. Then the value of n will be 404. Then the value of n will be 50. See, now the value of n is 50. Okay. 50 is less than 8? No. So the control will go to the else part. Now here, n divided by 8 is passed. What is n? 50. 50 by 8, that is equal to what? 50 divided by 8. 8 6 are 48. So the quotient is 6. And what is the remainder? 50 modulus 8. See, 8 6 are 48. Remainder is 2. So here the remainder value is 2. Since the method is calling itself again, now let me write the method once again. Okay. Public static string get octal int n. If n is less than 8, return n concatenated with one empty string. Else, let me call the get octal method and write here n by 2. Same thing, huh? Not n by 2, it will be n by 8. Yes. N by 8 concatenated with n modulus 8. N modulus 8. Okay. Now listen. See here the method called itself get octal. So the value 6 is passed to n. That is the reason why I told the value of n will become 6. Now listen. Now the base case has approached. N value is 6 now. Yes or no? What is the value of n now? It is 6. 6 is less than 8. Yes. So we need to return n concatenated with empty string. What is n? 6. When concatenated with empty string, the value 6 is becoming a string value. The value 6 is becoming a string value and it is getting returned. Where is it getting returned? Now let me change the color to make you understand. See this value 6, it is getting returned here. It is getting returned here. So here we are getting the value 6 in string format. So if one operand is of type string, so plus operator will behave like concatenation operator. So this 6 and this 2 will get concatenated. Okay. This 6 and this 2, okay, will get concatenated. So it will become 6, 2. It will become 6, 2. Okay. So you can see, right, see the right side. In the reverse order, we are concatenating. That is the reason why I called the method before plus sign and then concatenated the remainder which will be obtained after dividing the current value of n by 8. Okay. Now 6 2, this string value 6 2 will get returned here. It will get returned here. So 6 2 will get returned here, and with this 6 2, okay, with this 6 2, this 4 will get concatenated and the value will be 6 to 4 in string format. See, the return type of the method is string only and string value is getting returned. So this value will get returned here. Okay. So here the value will be 6 to 4 in string format. And this value will get concatenated with what? This value 6 to 4, which is returned. Okay. Will get concatenated with 2. And we will get 6 to 4 concatenated with 2. So 6 to 4 2. So this is the value which will be returned. Okay. So 6242. 6242 is the final value or required value. Yes or no? See, 6242 in reverse. So what is the base case in case of decimal to octal? If the value of n is becoming less than 8, so the process should stop. The process should stop. And what we have to return in such case, we have to return that particular value of n, but in string format. So, but in string format, that is the reason why I used empty string and concatenated with that value of n under the base case, So I wrote, if n is less than 8, return n concatenated with string, empty string. So that integer value of n becomes a string because the return type of the method is a string. Clear or not? Clear, na? Now let me write the program for you and check whether it is working properly or not. So create a class, give any name, double click over it, Control A, backspace, import import java.util.scanner scanner. Okay, public class deciml decimal to octl octal converter octal converter public static static void void main capital str ing string array space args. Okay, here create the object of scanner. Scn is equal to new scanner, and here write system.in. Okay, give a message to the user system.out.println, enter an integer value. Enter an integer value. Okay, so int n is equal to a scanner object dot next int, then int, not int, string 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 octal equivalent. OE means octal equivalent is equal to get octal, get octal. Okay, and then let me pass n here. Okay, just display it system.out.println what the octal equivalent, the octal equivalent of concatenation sign n, concatenation sign is equal to concatenation sign OE. Okay, close the main method. Now let me define the get octal method. public static static string string get octal, get octal int n. Okay, so this will be the recursive method which will accept an integer value and return the octal equivalent in string format. That is the reason why the return type of this method is string. Now what is the base case of this recursive method? If value of n is becoming less than 8. Okay, this is the base case. So the method has to return that value, but n, the data type of n is int and the return type is string, so I will concatenate empty string to make it a string value. Okay, else now the recursive case is return get octal n divided by 8 concatenated with what? N modulus 8. Okay, Control Shift I, Control K, no syntax error, no syntax error. Now let me call enter an integer value. So what is the example that we have taken? 3234, and the output should be 6242. So let me give 3234 and see. 3234, 3234. Okay, enter. The octal equivalent of 3234 is equal to 6242. See, the answer is 6242. The answer is 6242. Yes or no? Okay, clear? 6242. Okay, now what if I give 65248? 65248, 65248, 65248. The answer is 177340. Now let me check whether it is working properly or not. Listen. So what is the decimal number? 65248. It belongs to decimal number system. So the base is 10 is equal to question mark base 8. So we need the octal equivalent of this decimal number. Now let me divide 65248 divided by 8. 8 8s are 64, remainder 1, 12. 8 1s are 8, 9, 10, 11, 12, 44. 44. 8 5s are 40, 48. 8 6s are 48. So remainder is 0. Okay. 8 1s are 8. Now 1 is a fresh number, so 0. Okay, 15. So 8 1s are 8, 9, 10, 11, 12, 13, 14, 15, 76. 8 9s are 72. So 76 minus 72, it's 4. Okay. Now 8. 8 1s are 8, remainder 2, 21. 8 3s are 24. So 8 2s are 16. Okay. So 8 1s are 8, 21. 8 2s are 16. 21 minus 16, it's 5, 59. 8 5s are 40, 8 6s are 40, 8 7s are 56. 8 7s are 56. Remainder is 3. Remainder is 3. Okay. 8. 8 1s are 8. Remainder is 4. 47. 8 6s are 48. So 8 5s are 40. Remainder is 7. Remainder is 7. Now 8 2s are 16. So 8 1s are 8. Remainder 7. Remainder 7. Now 1. 1 is a value which is less than 8. So the process stops here. So the octal equivalent of what? 6 5 2 4 8, whose base is equal to 10 is equal to 1 7 7 1 7 7 340 340. Okay, so this is the octal equivalent of this number. So you can see 1 7 7 1 7 7 340 340. So the program is working fine. Clear? Clear or not? Okay. So you can take the screenshot. Okay. Take the screenshot of this also. Take the screenshot of this also. Take the screenshot of this. Now this is the program. Take the screenshot. Okay, this is the main method. Okay, and this is the get octal method. Take the screenshot. Okay, so practice this. If there is any doubt, you can write in the comment section. Okay, or you can ask in the class group also. So thank you so much. Bye-bye. Take care.